Betelgeuse, the red giant star on the verge of a cosmic explosion. Betelgeuse, a red supergiant star located in the Orion constellation, has been captivating both astronomers and the public alike for its enormous size, vibrant color, and unpredictable behavior. But recent observations suggest that Betelgeuse may be on the cusp of a dramatic and possibly catastrophic event in its life cycle. With the help of cutting-edge tools like the James Webb Space Telescope, astronomers have been monitoring the star's unusual fluctuations, leading to questions about the potential for a supernova, a massive stellar explosion that could forever alter the night sky. A gigantic star on the edge of change. Betelgeuse is a red supergiant, a type of star nearing the end of its life cycle. It's about 10 to 20 times the mass of our Sun and could easily surpass it in size. If it replaced our Sun, its surface would extend all the way past Mars, swallowing Mercury, Venus, Earth, and even Mars. This immense size is not just a spectacle. It also represents Betelgeuse's current stage in the life cycle of stars. After exhausting its hydrogen fuel, the star has shifted to fusing helium, and now it is expanding and cooling. Betelgeuse is about 8 million years old, young in human terms but ancient in cosmic terms, and it's nearing the end of its life. Over time, Betelgeuse has evolved from a hot blue star into the cooler red supergiant we see today. Its red color results from a much cooler surface temperature, around 3,500 Kelvin, compared to the Sun's, around 5,500 Kelvin. This change in temperature causes Betelgeuse to emit light at redder wavelengths, which is a key indicator of the processes taking place within the star. Historically, Betelgeuse was yellow in color until around the 9th century, when astronomers began to observe its gradual shift toward red, signaling its advancing age. The mystery of Betelgeuse's variability. Betelgeuse's variability is another fascinating aspect of this star. It is a semi-regular variable star, meaning its brightness fluctuates over time. This periodic dimming and brightening cycle has been known since at least 1836, when Sir John Herschel documented its behavior. However, what sets Betelgeuse apart from many other stars with similar variability is the unpredictability of its changes. While many stars follow a steady pattern, Betelgeuse's changes are more erratic, suggesting there are still many unknowns about what is happening inside this enormous star. In recent years, a particularly surprising event occurred. In 2019, Betelgeuse began to significantly dim in what's now called the Great Dimming. The star's brightness dropped rapidly, by about 0.01 magnitudes per day, and by early 2020, Betelgeuse had become much dimmer. Even in areas with substantial light pollution, observers noticed the change. This dramatic dimming sparked a wave of theories about the causes behind it. Some suggested it was due to dust clouds blocking our view of the star, while others speculated it was a precursor to a more dramatic event like a supernova. Are we on the brink of a supernova? Astronomers have been closely studying Betelgeuse's behavior in the hope of understanding what these fluctuations mean for its future. The light we observe from Betelgeuse today actually left the star about 725 years ago, so the changes we see may not reflect its current state. However, the timing of these dimming events and the irregularities in its brightness have led some scientists to suggest that Betelgeuse could soon be on the verge of a spectacular explosion. Betelgeuse's future, as a red supergiant, is likely to end in a violent supernova. When stars like Betelgeuse reach the end of their lives, they run out of fuel to sustain nuclear fusion, causing their cores to collapse and triggering a massive explosion. If Betelgeuse were to explode, it would be one of the most significant cosmic events in our night sky, visible even in broad daylight. However, the exact timing of such an event is still uncertain. It could happen tomorrow or it could take thousands of years. What is certain is that Betelgeuse is an extraordinary and enigmatic star that continues to provide astronomers with new insights into the life and death of stars. In summary, Betelgeuse is a red supergiant star undergoing significant changes as it nears the end of its life cycle. Its extreme size, unpredictable brightness, and recent dimming events have raised the possibility that it might soon explode in a supernova, an event that would be visible across the universe. As scientists continue to observe Betelgeuse with the help of the Hubble and James Webb Space Telescopes, we may be witnessing the final stages of one of the most impressive stars in the sky. Recent observations of the variable star Betelgeuse have provided new insights into how stars like it evolve and change. These variable stars continuously expand and contract, causing fluctuations in their brightness. Researchers were able to study the layers above Betelgeuse's surface, which is heated by the star's swirling convection cells. Due to the Hubble Space Telescope's ability to avoid bright light interference, further analysis of its spectra, taken in 2019 and 2020, revealed the speeds at which material was moving through Betelgeuse's upper atmosphere and the consequences of its mass loss. The spectra primarily showed magnesium, indicating that material was being ejected from Betelgeuse's surface at speeds of about 200,000 miles per hour. This material traveled thousands of miles away from the star, eventually forming a dust cloud that obscured the star's light for several months. Researchers, including Dupree and her team, estimated that twice the expected amount of material was expelled from Betelgeuse's southern hemisphere. Although all stars lose mass over time, Betelgeuse's mass loss occurred at a much faster rate than the Sun's, which raised questions among astronomers about whether this event could signal an impending supernova. At a distance of about 725 light-years from Earth, Betelgeuse adds to the intrigue of the situation because any supernova explosion would be observable from Earth, offering an exciting opportunity to study a supernova up close. However, the key question remains: what does this dimming of Betelgeuse mean for its future? Could it be a precursor to a supernova, or is it merely a temporary fluctuation in the star's long and complex life? Several hypotheses have been proposed to explain the sudden dimming. One well-known theory suggests that it was part of the supernova process, with the star nearing the end of its life. Another theory posits that dust, possibly expelled by the star itself, could be blocking our view of it. Red supergiants like Betelgeuse shed material, which can accumulate into a dust cloud thick enough to obscure their light. A third hypothesis examines changes in the star's photosphere, its outermost layer, suggesting that alterations in the photosphere could affect the star's apparent brightness. To address this mystery, astronomers combined various observational methods, including spectroscopic analysis, to gain a deeper understanding. These investigations revealed that Betelgeuse's effective temperature had dropped, indicating that the star might have been shrinking due to a large dark spot on its surface. The temperature drop, which amounted to at least 170 Kelvin around the time of the dimming, supported this idea, suggesting massive changes in the star's surface. The role of the Hubble Space Telescope in this research was crucial. It provided detailed observations that helped scientists understand the event. Hubble's data showed that the dimming of Betelgeuse was likely caused by large amounts of hot material being ejected into space, forming a dust cloud that blocked light from about a quarter of the star's surface. This material was primarily composed of plasma, which formed dust grains as it moved through Betelgeuse's hot atmosphere into cooler outer layers. This cloud of hot plasma, detected by Hubble in January 2019, obscured part of the star and helped confirm the hypothesis of mass loss. The realization that Betelgeuse was losing mass at a much faster rate than previously thought led to new insights into how stars evolve, especially red supergiants. These stars, including Betelgeuse, are not unique in their behavior. Other supernova events like SN 1054 and SN 1987A have provided valuable data about stellar death and the formation of new elements. For example, SN 1987A, located in a nearby galaxy, gave scientists a close-up view of a supernova explosion and its aftermath. Such events contribute to the cosmic cycle by dispersing heavy elements and influencing star formation. If Betelgeuse were to become a supernova, it would produce a spectacular light show visible from Earth. The explosion would be brighter than the full moon and might even be seen during the day. This would provide an incredible opportunity for astronomers to study the final stages of a massive star's life and the formation of new elements. While such an explosion would be dramatic, the distance between Earth and Betelgeuse means that it is unlikely to pose any direct threat to our planet. In any case, the observations of Betelgeuse's potential transformation will continue to advance our understanding of stellar evolution and astronomical phenomena. The role of red supergiants in the development of stars is crucial to our understanding of the universe. These stars represent the final stages of a massive star's life before it undergoes a supernova explosion. Their large size and relatively short lifespans make them ideal subjects for studying the end stages of stellar evolution. Red supergiants also play an essential role in the formation of heavy elements, which are key to the creation of planets and life as we know it.